Hello, crypto hunters. What's up? Welcome back. This is day 10 of the 21 days challenge on blockchain fundamentals. Today, we're gonna cover 5 sections. Yes, 5 sections. So, to give you a summary, we're gonna talk about types of miners, proof of work, miners cost, proof of stake. We're gonna talk about delegated proof of stake. We're gonna talk about proof of importance. So stick with me for the coming minutes, and we're gonna answer all these questions. So without further ado, let's jump right into it. So we have homework on types of miners. 2 questions. Question number 1. Let go. What is a GPU and why is it better at mining? Well, a GPU stands for graphic processing unit. So it's this is the hardware that we're talking about when we talk about hardware for mining. So a GPU it's better at mining because it's efficient at manipulating the graphics. So that's just the technical. Those are the technical fundamentals of a graphics card. Actually, I'm not gonna go right into details, but let's just know that the GPU is very effective instead of a CPU. What we're gonna cover in question number 2, and it gives a better hash rates than the CPU. So just know that GPU is better at mining than CPU. And when you come to GPU, the types of GPU you want to be looking at are gaming GPU cards. So we have the NVIDIA GTX 1060, I think 1070 I. So those are all. They also have Radeon, and there are some other ones. So, but we're gonna be covering that on another episode, just especially about mining. But that's for the future. So, question number 2: why is a CPU not a common choice in Bitcoin mining hardware today? Well, actually, this is because economically it's not possible, or it's not usable. So they are too expensive, and they produce too low hash rate in order for you to make a good return on investment. So that's basically the reason. And when it comes to hash rates, ASIC miners and GPU are way better. They outperform CPUs. So those are the questions. So now we have homework on proof of work. So the mining cost. Here we have 2 questions. Question number 1: what cost should you take into account if you want to start mining? There are 2 main costs, but there's a third one. So the first one, you're gonna take, of course, the cost of your hardware. So remember we talked about GPU. So to buy these graphic cards, it depends on also on what you want to do. Are you going to build up a mining farm, or are you going to build just a mining rack with some rigs on it, or are you just going to build a bunch of computers? So your hardware is going to cost you, so you have to take this cost into consideration. And then you have to also look at the electricity costs. So those are the 2 main costs. And of course the third one is the pool fee. I keep forgetting this one, but this is also very important, because when you join a pool to mine, there's always going to be a fee associated with it, because if you're mining on your own, your probability is way lower than when you join a pool. So I think the organizer of this pool is always going to ask for a fee. So those are the 3 main costs you have to take into consideration. So question number 2: why can it be a risky investment to invest in mining hardware? Well, because many cryptocurrencies they are mostly moving to another consensus algorithm. So there are a lot of crypto projects moving over to proof of stake or delegated proof of stake or other algorithm consensus. So this makes it a lot more competitive for the mining community, because a lot of miners are now being concentrated on very few projects. Now, those were 2 questions on proof of work, mining cost, and now we have homework on proof of stake. Here we have 3 questions. So question number 1, what incentivizes miners to produce valid blocks in proof of stake? So actually in proof of stake, you will have to lock up your funds. So this is required in order for you to make valid blocks. So that's the incentive right there. So you're gonna invest, you're gonna buy up, let's say, your coins, and you have to give them up as collateral. So if you're a bad boy, you get punished. Question number 2. What is the deciding factor behind who gets to produce the next block? So this is pure randomness between stakeholders, although the higher the stake, the better the chances of winning. So in this sense, that is where all this saying comes out, where they say the richer get rich and the poorer, well, if you have more money for proof of stake, your probability is of course way higher. Why are there benefits of using proof of stake instead of proof of work? So there is no power consumption. This is from an environmental standpoint. So you have a linear scaling presence in proof of stake and not in proof of work. So chances of being the next block creator are in line with how much stake or funds that are like invested. But of course, like I said, there are doubts there. So always keep in mind, people who invest more than you probably have more chances. So moving on. So we have homework on delegated proof of work. Question number 1, what is the difference between proof of stake and delegated proof of stake? So in proof of stake, actually you have every holder that can be elected to create new blocks. So if you have your collateral up in proof of stake, you're a holder, so you can be elected to create blocks. Meanwhile, in delegated proof of stake, the token holders are going to elect a witness or a validator, and this validator will validate the blocks for them. The most vote holders win. The person with the most votes is going to win. This is of course going to create a competition among the witnesses, so competition for people's votes in this case. Those were the questions. Moving on, the last part of day 10, we have homework on proof of importance. A lot of proofs in this challenge. So 3 questions here. What determines an important node? That's question number 1. So an important node is obviously going to depend on various implementations. So for example, how old is the node, so that's the node age, and of course also the node rating. So how is the node rated? So what ratings do the node have? So all this is going to be different implementations that are going to be taken into consideration when determining the importance of a node. So moving on to question number 2, what sets proof of importance apart from the other consensus algorithm from an economic perspective? Well, in proof of importance or proof of existence, wealth doesn't matter. So in proof of work and in proof of stake, of course, the more fund you have, the more you can invest. So in proof of work, here you're gonna invest in your hardware, In proof of stake, you're gonna invest in more funds, more collateral, whatever. But in proof of existence or proof of importance, here actually your wealth doesn't matter. So this is what makes it very interesting. Question number 3: what are the challenges for proof of importance? So there are actually a few. Perfection of the algorithm plus increase of the Byzantine fault tolerance. So this is a challenge, of course. So how are you going to actually determine importance? So this is something they need to work on in order to perfect this algorithm. And another one is how to stop bad nodes from taking over the network. And also, what happens if bad nodes give each other high importance? So what are they going to do about that? So these are all problems or challenges that needs better solution before mainstream adoption. So those were actually the 4 or 5 sections for today. So we talked about types of miners, we talked about mining costs, we talked about the various proofs or the various consensus algorithms. So we talked about proof of work, proof of stake, delegated proof of stake, and proof of importance. So those were my answers on all these questions. If you want to add something to this, you can always leave a comment down below. If you enjoyed the content and you like what you see, push up the like button. And for more crypto related videos or content, always subscribe to this channel. And for all of you who are out there hunting cryptos, I'll say happy hunting and see you on the next video. I'm out.